Hey, let's rationalize some denominators. Here we go. 12 over root 6. Now remember, come on guys, you gotta turn that denominator into a perfect square. You can't have square roots in the denominator. So you can multiply it by root 6, but if you do that to the denominator, you gotta do it in the numerator too. So we'd have 12 root 6 over the square root of 36, and the square root of 36 is obviously 6. 12 root 6 over 6, and then you could divide the big boy numbers. The 12 divided by 6 would be 2, so you got 2 root 6. Easy peasy, squeezy lemons. Now, another thing you could do if you have a radical in the denominator, you could simply just bring it up to the numerator and then make the denominator just the regular version of that number. So it'd be 12 root 6 over 6. Kind of saves you a step if you know what you're doing. We practiced that in class a few weeks ago. Now here we got root 18 over 3 root 2. You can simplify the radical stuff with radical stuff and the regular numbers with regular numbers. So like 18 and 2. 18 divided by 2 is 9. So we're left with root 9 over 3. Right? Square root of 1 is 1. Get rid of that. So we just have 3 over 3, which is 1. Yes! Full root 5 over the square root of 10. Now I'm going to simplify the 5 over 10. 5 goes into 10 twice, so really we would just have 4 over square root of 2. Now remember our little trickery. We could bring the root 2 to the numerator, 4 root 2, and then the denominator just becomes regular 2, and then simplify what you can. 4 over 2 is just 2. 2 root 2. Oh, 5 over the square root of 7. Oh, well. Bring the root 7 to the numerator. 5 root 7 over regular 7. Now you could multiply by root 7 over root 7 and then simplify, sure, but we're trying to save some time here. 12 over root 72. Now you could break up 72 into 36 times 2 and simplify that square root, or we could just turn it into a perfect square. So like 72 goes into 144, so you could multiply it by 2, but if you got to do that in the numerator, wait, if you do that in the denominator, you have to do that in the numerator as well. So we have 12 root 2 over the square root of 144. 12 root 2 over 12. Then divide the 12s. You just got your root 2. Here's where it gets a little dicey. 3 minus root 3 over root 3. We gotta multiply by the square root of 3, but there's 2 terms in the numerator. So now we have to like distribute that root 3. Root 3 times 3 is 3 root 3. And the square root of 3 times the square root of 3 is just the square root of 9, which is 3. Denominator, root 3 times root 3, 3. So we could factor the numerator. They have a common factor of 3, which would leave us root 3 minus 1 over regular 3. And then you could simplify the 3 on the outside. So we're left with root 3 minus 1. Yeah, or if you were putting it in proper form, you'd put the root at the end. So you'd have to just check what they have in the multiple choice options there. This one's kind of the same deal, except we have 2 terms in the denominator. And when you're rationalizing with 2 terms, you have to go with the conjugate, which means you just make the plus and minus, you just make it the opposite. Because this will give you the difference of squares. And you don't even need to FOIL the denominator. Numerator, we got 1 times 3 is 3, minus root 2. Denominator, you don't have to FOIL it because the difference of squares, you square the first term, you make it a minus, and you square the last term. Square root of 2 squared is just regular 2. So the denominator is 9 minus 2, which is 7. The only other thing you gotta check is see if you can simplify, but you can't. Same kind of deal here. So we're going to multiply by the conjugate, which would be 3 minus root 5. We got to do that numerator and denominator. And we are going to have to FOIL in the numerator. 1 times 3 is 3. 1 times root 5 is root 5. Negative root 5. Negative root 5 times 3 is negative 3 root 5. And negative root 5 times negative root 5 is positive 5. Combine your like terms. 3 plus 5 is 8. Negative root 5 minus 3 root 5 is negative 4 root 5. Now if you want, you could take out our greatest common factor here, which would be 4. Leaves us with 2 minus root 5, because maybe we'll be able to simplify the 4. Denominator, you square the first term, 9 minus, square the second term, 5. 9 minus 5 is 4. So our whole denominator is 4, and then we can simplify the 4 over 4 part. We're left with 2 minus root 5. 2 more problems. Oh, and this one's just a true delight. Multiply by the conjugate. There's going to be all kinds of FOILing on this one. All kinds of FOILing. Let's do the numerator first. Root x times x is x root x. Root x times root y is root xy. Y times x is xy. And y times root y is y root y. So we can't combine any of these terms. There are no like terms here. So we'll just go ahead and do the denominator. You square that first term. X times x is x squared. You make it a minus. Root y times root y is y. That's it. You can't simplify none of that no more. One more. Oh no. Oh no. A cube root? Oh dear. You can't have cubes in the denominator just like squares. But we could treat it as 2 separate cube roots. Now 3 is 3 to the first, a to the first. We need them to be to the third power. So we're going to need 2 more 3's. We're going to need 2 more a's. So we got to do that up top too. But 3 squared is 9 a squared. So up top, if we multiply it, 2 times 9 is 18, a to the second. Denominator, we got 3 to the third, which is 27, but we could write it as 3 to the third, a to the third, and then when you cube root those, that'll just be 3a. Guys, that was fun. We'll see you on page 4.